Hello everyone, myself Sabina Devi, Assistant Professor, Department of Physics. In this video, I am going to explain about design thinking applied to the laser project. So in previous video, I explained about working under constructions of helium neon laser and the case study on helium neon lasers, right? So in this video, how design thinking will be applied to the laser project. Okay. So design thinking applied to the laser project. So this presentation explores how design thinking principles can be applied to the projects involving laser technology. So we will delve into a user-centered interactive problem-solving approach to integrate laser capabilities into innovative creative endeavors. So the process is structured around the five key stages. So we know about design thinking, right? So in design thinking, we have five steps. So these are empathy, define, ideate, prototype, and testing. So this will be the innovative, creative approach. So this will be the user-centered, interactive problem-solving approach. So this will be very much helpful in the very much helpful to apply in the ASA project, right? So the empathy. So empathy is nothing but the understanding user needs with laser technology. So the empathy stage is crucial for understanding the end user's perspective. So this involves observing and engaging with users as they interact with the laser cut products, right? So for instance, consider the student designing laser etched acrylic inserts for LED sculptures. By closely observing their creative process and their challenges, we gain insight into their needs and frustrations, right? So seeing through the user's eye helps identify pain points such as the difficulty in swapping insert or the achieving desired lightning effect. So the deep understanding of user's perspective is the foundation for developing meaningful user-focused laser design solutions that genuinely address for their needs, right? So this will be the empathy part of understanding the user needs with the laser tech, right? To define the framing the laser design challenge. So how to design the challenge? Okay, first one is problem statement refinement. So transform broad observation from the empathy based on a clear and actionable problem statement, right? So first one is the problem statement refinement, right? So second one is example challenge. So how we can design customizable, visually appealing laser cut inserts that fit precisely into the 3D printer base, like effectively diffusing LED. So how we can design customizable? This is the example challenge, right? So specifying design goals. So third part is specifying design goals. After the question, so we have to specify the design goals. Okay. So utilize research, user interviews, and feedback to specify the exact design goals. These are all the specifying design goals. Then defining the constraints. So our constraint is to produce the accuracy, right? So establish limitations such as the size, fit, and accuracy, light diffusion properties, and the need for users creatively in design. These are the defined constraints, right? The third part is ideate. So the first part is empathy, second part is define, third one is ideate. So in ideate, generating laser design concepts, right? So the ideate stage is where creativity flourishes, pushing the boundaries of the what possible with the laser technology, right? So first one, brainstorm diverse ideas. So generate a wide range of concepts for a laser cut shape. So indicate the patterns and various materials beyond standard acrylic. Okay. So encourage creative exploration. So think about the multiple insert designs, layering layering technologies, and different use laser etching styles to maximize the visual impact. So this is increasing creative exploration. The third part is collaborative group work. So foster an environment for teamwork, exploring both functional and aesthetic options through the shared ideas, right? So fourth part is tools for concept sharing. So utilizing skills, advanced digital design tools and rapid concept sharing and session to visualize the visualize and discuss the ideas efficiently. So these are all the ideas for to generating the laser design concept. So fourth one is prototype. So building a laser cut model, right? So fourth one is prototype. So to build a laser cut model, in the prototype stage, ideas transcend from the concept to tangible forms, right? The primary goal is to create the physical laser cut acrylic insert. So these prototypes are then combined in 3D printer basis, right? So designed to house LED matrices and enabling the testing of edge lighting effects, right? So this phase involves the multiple interactions to refine critical elements such as slot dimensions for precise fit and the clarity of engraving patterns. So it's a hands-on process and experimentation where digital designs are brought to life and allowing for the direct evolution and the refinement of the physical product. Okay, so this will be the prototype to build the laser cut model. So, so final step is test, evaluating laser prototypes with the users. So first, user feedback collection. How to collect user feedback collection? So gather the direct feedback from the users on the aspects like fit and overall visual appeal and the ease of the shopping insert. Then LED lighting effects. So rigorously test how LED lighting interacts with the various laser etching patterns to achieve the desired visual outcomes. Okay. So third one is issue identification. So pinpoint any problems such as tolerance, mismatches, and undesirable light bleed and excessively design complexity. These are all the issue identification uh, will get from the users, right? So then impact improvement. So based on the issue identification, we have to improve the best, right? Based on the comprehensive testing results, so impact prototypes will be implemented and necessary improvements and enhancement. These are the testing part. Okay. So interaction, iteration, and learning in laser design thinking. So embrace trial and error. It's a common for projects to record 15 plus sprints and laser cut before achieving the optimum result, right? So design thinking thrives on a iterative cycle. So each test provides valuable insights that inform to the next iteration, continuously enhancing usability and aesthetics. Engaging users continuously throughout this process ensures that the evolving designs meet their needs and gain their buy-in. So this includes prototyping the LED patterns in parallel, ensuring they perfectly complement the evolving laser cut designs, creating the harmonious final product. Thank you all.